Hey, I'm Joey Henderson. I've been in the HVAC field for 30 years, teaching heat and air conditioning for 25 out of those 30. I've been still in the field. I've worked for manufacturing, being a technical support and trainer. And also with heat and air, as usual, we pick up electrical as well. So today we're going to be talking about the TUE-200 trainer, TUE-200 trainer here. With iConnect training, and helping me is Nick with iConnect training, and Nick is going to help me show what we're going to do for helping the students understand residential electricity coming into the home. So the first thing I want to do is, Nick, if you would just point out the components that we have here on the TUE-200.
Sure. So here we have our power feed to the whole system with two hots, a neutral, and a ground. So that's going to come up and around the frame through our stud wall and into our power meter. Then we're going to go into our circuit breaker panel, and then it's going to be distributed to all of our duplexes, our switches, and everything inside the house with our circuit breakers. So we've got single pole switches, we've got three-way switches, different amp rating receptacles. We've got a dryer receptacle or a 240 volt receptacle. We've got a low voltage transformer running a doorbell system, three-way switch operating this light. We've got ceiling lights, and we've got different switches over here powering more duplexes with the tabs on the side broken off to show how you can keep one hot at all the time and operate the other one with a switch.
Okay, great. Thank you very much. Okay, well, one thing I want to show you is I've got 6 lessons that I believe you could use to teach your students about residential electricity using the TUE-200. And the first thing I like to show is the electrical panel and how it distributes that L1 and L2 coming into it. So Nick, if you could, can you remove that electrical panel cover so we can see the L1 and L2 coming into it? We're going to take a look inside the electrical panel behind the cover where all the breakers are and show how the L1 power and L2 power come in, as well as where the grounding is. So we'll get a good view of the inside of that box there. And what we're doing is we're giving the student an opportunity to learn how to use their meter, how to measure with it, also to be comfortable around high voltage, and to see how to measure the voltage coming into that panel. So Nick, go ahead and read across L1 and L2 and see what kind of voltage you got.
That's 211.5.
Great. Now let's go from L1 to ground.
$124.4.
124.4 and L2 to ground.
120.8.
Okay, so we can show right there that from one leg of power to ground is not going to be added up to be 208 volts. We're showing that how different power comes in from the transformer in the houses. You may have 208 volt, 220 volt, but when you go from L1 to ground, you're going to get that 120 to 124 volts. And that's what we're going to use to power up our outlets and our lights is our 120. But when we need 208 or 240 volts to run larger loads like a dryer, we'll use both sides of that, the meters there. So if you would, Nick, show how L1 comes in and how it curves around through the meter there, through the circuit box, and how L2 crosses over.
You can see our L1 is all down this side, L2 is down this side, but as each leg drops off into the center, it alternates tabs. So it's L1, L2, L1, L2. So in any place where we have a 240 volt breaker, we're going to jump across L1 and L2 on the same side, just like this 30 amp double pole breaker.
Excellent. So in order to get one leg of power to an outlet, we have a single pole breaker. And point to that single pole breaker there, Nick. All righty, and then also, what's your number on that breaker?
15.
15. So that indicates that that breaker will protect the wire up to a 15 amps of capacity going through it. And that's important to note that the breaker is sized to protect the wire that is in it. So if you'll look, we only got one wire going in that single pole breaker. You can point to that if you want with your leads. And then we've got the other part of that wire coming up, and it goes over to the neutral. So the neutral bar there.
Right, so we've got our neutral bar all the way up here, and that's connected to our neutral right at the top, and another neutral bar following the L2 portion.
All right, and then show the ground wire, if you would, in that circuit.
So another ground bar all the way up this line.
Good job. So if you'll notice in the circuit panel, we've got all the grounds going to one bar there. We've got all the neutrals, which are the white ones, going to the neutral bar. And then if you look at a double pole breaker, so show that 30 amp double pole breaker there. That right there is two singles tied together, and they go across each of the legs of power. So right now, take your meter and measure the voltage coming out of that breaker, Nick.
We turn the breaker on.
All right.
And 210.5.
There you go. So that's our L1 and L2 together, making 210. And then go to the single pole there, turn it on, and check it to ground.
$123.8.
There you go. So now we've got a chance to measure a double pole breaker and a single pole breaker. And this is where you can take a moment to explain that a breaker trips whenever it gets too hot due to too much current going through it. So that would be if we've got too much amperage going through the wire to the breaker, and that breaker protects that wire from overheating and causing a house fire more than anything else. It also protects whatever it is on the other side and that outlet from overheating and burning up if possible to save it. Nick, now go over and show that 220 plug you got, that dryer plug. Notice that dryer plug has got a certain configuration, and that is an indicator of how much current that plug can handle. And we've got that plug tied into, does it go to that 30 amp breaker there, Nick?
Uh-huh.
Okay. And you might use that for a dryer. Also, another outlet that you might use for a 30 amp would be an electric stove, and also any other larger electrical appliances in the house. So, Nick, if you go over there, just take a volt reading real quick on that 220 plug or that 208 plug, and just show that we are sending 208 volts over to it.
Yep, 211.4.
There we go. And that's another way for the student to recognize what a high voltage double pole plug would be, in this case a 208 volt versus a single. Now go over to an outlet, a regular receptacle there, and measure those voltages there across the two slots.
Let me bump all these breakers on.
All right.
Is that like too much? Okay, so any duplex
just pick an
here?
outlet and show, if you go across it, what you're going to read.
124.4.
124, not 208. So if you go ahead and pick up one of those, that receptacle you had there you brought in with you. Now, if you look at that real carefully, we've got one side that we're going to put in the L1 wire, and the other side is going to be the neutral wire.
And our hot line going to there are colored in gold and neutral in silver.
Excellent.
And the green for ground.
And the green for ground. And that way, even though we've got two slots there, just like the larger plug, we've only got 120 because it's just hot and neutral, whereas the other one has got L1 and L2 going to it. All right, thank you, Nick. The second lesson I wanted to explain is, well, the single pole and the double pole and how that works, which we talked about. The third lesson is going to be following the electricity out of that panel. And Nick, can you pick the double pole circuit and follow it out of the panel and how it traces over there to that 208 plug?
So I'll follow my red and my black wire coming right out of my breaker,
There you go.
down out of the bottom of the box, through my stud wall, stapled up the stud wall, and then mounted on the back panel.
Very good. And it traces right away over there. And notice that it's a red and a black wire. That is for high voltage. That's for red is for one leg and black is for the other. Now, if you look at the 115 circuit, go ahead and pick that single pole circuit and trace it over to an outlet that it goes to.
Okay. So the one that I was testing is a 20 amp. So I can follow that line up here to my 20 amp breaker. So I'm coming down out of the box, through the wall, and right to my duplex.
Excellent. And notice that we've only got a white and a black wire. And so the black wire is the high leg and the white wire is the neutral. So the other lesson you want to teach is measuring voltages. So at this point, Nick doesn't have to do all of them, but I would have the student go and measure the voltages at each of these outlets so they can get a good understanding of how to do that. Sometimes you don't get a good read because you don't have a good connection. And then measure the double pole as well. Another thing there you want to look at is the different kinds of conduit we got. We've got the hard conduit down below where Nick is standing. We've also got the corrugated metal conduit, and then we've got the Romex wire itself. And if you look inside the walls, that wire that's going through the walls, it's not all individual wires. They're inside of a single sheet, and that's called Romex. And we use that in residential wiring. Mm-hmm. Each wire has its own size. The larger the number of the gauge of wire, the smaller it is and the less current it can handle. And this is where we want to talk about the average number 12 wire can handle a 20 amp. So if you look at that 20 amp breaker, we can put a number 12 wire on that 20 amp breaker that Nick was working with a minute there. A 15 amp breaker will handle a smaller size wire. Typically, we would put a number 14 wire on the 15 amp breaker. And if we've got a 30 amp breaker, that you can go up as big as a number 10 wire, which will handle the 30 amps. So wire gauges change and breakers are there to protect the wire sizes depending on what you need. The other thing I want to show you that we were going to talk about was the three-way switch and the single switch. So Nick, you got over there a light to your left there, is that correct?
Yeah, so this
and it's got three-way switches on there?
This has a three-way switch, so I can turn it off here and turn it on over here.
Good
Same
deal.
thing. Off here, then back on from over here.
Good job. And you notice they're far apart. So what I like to show here is Nick's got a three-way switch there out of the box. And if you look at that switch real carefully, you've got a common wire connector, which is black. And then you're going to have two more others up there, which is traveler wires. And then you have a ground connector there. Can you see that pretty clearly, Nick?
Yep.
Okay. So what a three-way switch does, this is a good time where you can bring up a diagram and show it to them, is that it allows you to take power and transfer it from one switch to the other and control one light with two switches. And the reason we do that is we have a room, a large room where we'll have two entrances into the room. And that way you can flip the light on no matter which way you come into that room. And that's the purpose for a three-way switch. And here we've got in our trainer a three-way switch. You can open it up. Part of testing is, you can power down the trainer here and pull those switches out, lay them down there in the wall and let the students come and wire them back up. And then you can test it. So it's a great way to check it. And then also we've got the single switches. And Nick was talking about how we use the single switches to connect to the outlets where we can have an outlet controlled by the switch, or we can have just the outlet hot all the time. and that's by removing the tab on that outlet. And you've got that, you got an outlet out of the box here too, Nick. You can show that tab real quick.
Yep.
All right. And while you're showing that tab, can you explain just a minute on how we use that tab to disconnect one side of that outlet?
And the way that these are, I can break that tab on both sides, feed hot all time, hot wire on my gold and neutral wire on the silver. And then this portion of the receptacle would maintain power at all times. And then I could also break power with a switch and run it to the other side so that you could leave a lamp plugged in and just operate that lamp on a switch while your other receptacle would maintain power.
Excellent. That's exactly right. That's the whole purpose for it. You can have a lamp, plug it in, and control the lamp by the light switch. There are a lot of rooms that are designed that they don't have ceiling lights. They only have the receptacles for lamp lights. And so you want to be able to control it by the light switch. So here you can show how to wire that up and disconnect it with that tab. All right, well, Nick, what we're going to do is we're going to show just how much a heat gun will work, and we'll see that meter increase speed as we use more wattage. So go ahead and plug in the heat gun. Now, just for, just to explain to the students that a heat gun is like a very super powered hair dryer. Would not want to dry your hair with it, but it's a very, very high powered, and it's going to pull a lot of current. So go ahead and plug it in and we'll watch that meter turn.
All right, here we go. Yeah, you can see that start to turn a lot faster. So even with two lights being powered, that meter is hardly using any power. But as soon as that amp draw from my heat gun starts up, you can see that spinning pretty rapidly.
Great. All right. And then if you turn it off, can we see it slow back down? So whenever we're using the heat gun and showing how the wattage on the meter increases, that's a good opportunity to explain that how volts times amps equals watts. So you could actually measure the voltage in the outlet that the heat gun's in, and then measure the amperage that is pulling on the circuit itself. So now we have an opportunity to use an amp meter as well. And now they can use real volts times real amps, and they'll come up with the actual wattage that heat gun is pulling and relate that to how fast that meter is spinning. All right, so here we've got the doorbell transformer, which feeds 20 volts over to a doorbell, and it goes down. If you'll follow the wire in there, Nick, show them, trace the wire coming out of the transformer and how it goes through the doorbell there.
So coming out of the transformer, we've got one leg coming down to a switch, which is a push button switch, back up, running up to the doorbell here.
All right, and let's show us how it works. All right, there we go. Ding dong, good job. All right, and so if somebody ever said, hey, my doorbell quit, you might go find a little transformer like that, and it will be wired to the usually under the floor on a stud or a joist, or up in the attic on a stud, and it looks just like that one right there. So just a recap on our 6 lessons. We're going to show how the circuit panel actually is got high voltage coming in, and how it takes the L1 and L2 and crosses those circuits over. We're going to show how a single pole breaker only takes L1. A double pole breaker will pick up L1 and L2 for like your dryers and your electric stoves. We'll explain how the breakers work. Lesson 3 will show how the electricity flows from the breaker through the wire to its respective outlet or light switch or 220 load. Lesson 4 is showing how a light switch is wired up and how it works. You can use a meter to show the power coming in, power going out. You can also use a meter to ohm out a light switch, see if it's open or closed. Lesson number 5 is going to be to show the types of switches, the 3-way versus the single. And then lesson number 6 is talking about the different types of conduit and when they're used and when they're not. The last thing you can do as a summary is go through the electrical codes and look at the highlights of how this is wired in and how we would do that in a residential home to follow codes. And that's the 6 lessons for the TUE-200.